So the entire unit we've been talking about linear regression, finding the line of best fit, and looking at the correlation of linear data. And so there's a little part of it that we talk about where, what if the data is not linear? What if it's a curve like an exponential, or what if it's a logarithmic, or what if it's something that's different than a linear regression? And we don't talk too much about it, but we should be able to recognize when something is not linear. So if you look at, this is just that pomegranate study that we talked about. If you look at the data, it does have a slight curve to the data points. So there are other types of regression besides linear. And these are the most commonly used. So if there's no transformation at all, it's just y hat equals a plus bx. You could see a square root regression, which a square root function, for those of us going back to algebra, the parent functions, square root is something that looks like this. Logarithmic, exponential, maybe it has a slight curve to it. The reciprocal, and then just taking the log of y. So basically, we are never going to have to transform the data ourselves, so we don't need to know how to transform it. The data will always be transformed for us, but basically, the process of data needing to be transformed is when the residual plot is curved. So basically, if you look at a set of data and the scatter plot may look linear to you, but when you go and plot the residual plot, it has some sort of pattern. So maybe when you make your residual plot, your pattern looks like this. That means that your data is not linear and that a linear regression would not be appropriate. So from there, you would need to move on to one of these transformations. And each time that the data is transformed, technically you're going back and looking at the residual for the residual to have no pattern. So let's say I transformed the data to be a natural log, because that's what I think would be good for it. So then I have the residual and then it becomes scattered. That means that the transformation would be a natural log function, or that would be something that it would need to be transformed to. But like I said, we don't ever have to transform it ourselves. This is just the process. So basically, calculate the LSRL. Is the residual plot scattered? If not, it gets transformed to one of these types of equations. And it's kind of a trial and error until you get to a point where the residual plot is scattered. So what this means to us in the context of what we would be tested on is being able to identify if the transformation is a good one, which if it is good, then what should the residual plot be? Scattered. And if it's a bad one, then it has a pattern. Exactly. So really the only part that we're tested on in this class is if we know how to solve based on a transformed equation. So this is often one of our class's favorite lessons because this is the most amount of algebra that we will ever use in this class is today. So here is the transformed equation, and we transformed it to be a log y. So we took the log of all the y's and created a scatter plot. And here was the regression equation after we transformed it. Here's the residual plot. And this is randomly scattered. So does that mean that the transformation was good? Yes. So a linear model of x and log y would be appropriate. If I were writing a script for a transformed equation, and I want you to make this in your notes underneath the PowerPoint slide, So sometimes they will ask you if the linear model is appropriate for something like this. The way that I would write my script for this kind of thing is I would say, since the scatter plot, the residual plot, my bad, contains no pattern, a linear model between x and log y, what's the context of the problem? I should probably write that in. What is x here? Number of days. Number of days and the log of, what's the y? Tumor volume. So between x and log y is appropriate. So really the only difference between the script of the original and the script of this is that now it's not just x and y, it's whatever the transformed variables are. Which it could be, like if you're looking at all the options, it could be x and log y, it could be log x, log y, it could be x and square root of y, it could be x and 1 over y. It's always going to give you the transformed equation. You just have to know how to interpret it from the equation.
So we'll never actually have to like go in and change.
No. Yes.
So say in this situation the residual plot does have a pattern,
Then it would still not be appropriate.
so you would say not appropriate, like using this method?
You would say it still contains a pattern, so it's not appropriate. But whenever you're given the transformed equation on the AP exam, it will be the one that is correct. It'll be the one that has a good residual plot. So you just have to know how to interpret it. Yes?
Would we not want it to have a pattern?
Because if the residual plot doesn't have a pattern, then that means that the scatter plot is truly linear and not some other shape. So if we transform it to logarithmic or exponential or square root or something else, we're actually converting it to be a linear in a crazy way. But we don't ever have to do that ourselves. We just have to know how to interpret it. So the second thing that they could ask you, 1, to interpret the residual based on the transformed, and then 2, to predict y values based on a certain x value. So the question for this example could say, what would the predicted average tumor size be 30 days after the injection of cancer cells? So I'm going to plug in 30 for x, and I've got log of y hat equals 1.226 plus 0.041 times 30. And my goal is to get y hat by itself. So what would my first step be into solving for y hat? Simplify the right side. So go ahead and type in 1.226 plus 0.041 times 30 and tell me what you get. 2.456. That's fun. Okay, so how do I, what is the opposite function of a log? How would I get rid of that log on the y?
You do the circle thing, so it's log base 10.
Log base 10, right? Because there's no there's no base there, so we assume that it's 10. So y hat would equal what to what? Yeah.
10 to the 2.456.
Good. And you can actually use in your calculator by hitting second log. It actually goes ahead and does that function for you. And then if you hit the up button and select the full decimals instead of rounding it, it'll give you the exact answer. So So in your calculator, if you hit second log, and then you click the up button to select that 2.456 and hit enter, it'll actually insert it in there for you. So make sure that you keep all of the decimals, and then that'll get you the exact answer. So what do you end up getting? 285. Perfect. 285.759.
And that's if it asks you like for a specific like certain number of days or certain number of
Mhm.
whatever.
Mm-hmm. All right, are there any questions about 1 through 5?
No.
All right,